Trig. So here we go. First of all, in your calculators, when we do trig, because all our angles are in degrees, you want to make sure that your calculator says degrees on that home screen. Oh, you don't see that? Okay, so then if you go to mode, click on mode, and then the fourth one down, you got radians and you got degrees, and we are using degree mode. So once you make sure degrees is highlighted, then you can quit. Second quit to get out of there. So trigonometry is the study of triangle measurement.
Tangent, cosine, oh God.
The study of triangle measurement. Wyatt, I can hear you. It hurts my brain. Okay. Your notes? All right, here we go. So sine, cosine, and tangent are our basic trig functions that we're using in this class. They're the big three. And most of the time when I'm teaching trig to students, what I get or hear is, but I just don't understand what sine means. Okay, I just don't understand what cosine means. Okay, and all it is it's a word that they're using to tell us which sides of the triangle to pick. And so when you hear the sine of something, that sine is telling you a pair of the legs of the triangle. In this case, the sine ratio tells us to take the opposite and the hypotenuse sides. Okay? Cosine tells us to take the adjacent and hypotenuse sides. All right? And tangent tells us opposite and adjacent. And those are the pieces of the triangle that we're going to pick. So what does that mean? I'm just going to jump right to my little mnemonic for remembering this. Have you heard SOHCAHTOA?
Yeah.
SOHCAHTOA. And so I write it a little differently because I'm a math teacher. We're going to write so, S-O over H. Big S, O over H. S stands for sine. And then we have ka, C, big C, A over H. That's ka, C-A-H. C and then A over H. And then toa, T-O-A. T and then O over A. So SOHCAHTOA is how we remember which legs to pick. And the other thing I want to mention is that we abbreviate sine, cosine, and tangent with just 3 letters, but I never want to hear sin, cos, and tan. All right? That just makes me angry, okay? Because that's not what they are. They are sine, cosine, and tangent. So please, there is no sin in math. We aren't hanging Pythagoras. All right? There is no sin. It's sine. All right? It's not cos. It's cosine. Okay? And tangent. Just use the whole word. The other thing that's really, really, really important is we cannot figure out the opposite and adjacent unless we know the angle that we are looking from. So I want you to input here. It should be sine. This letter is theta. T-H-E-T-A. This is the Greek letter theta, and it's just a circle with a horizontal line through it. We cannot figure out the opposite and adjacent without knowing where we are looking from. They change based on where you're looking from. So it's really important that you always have sine of some angle, cosine of some angle, and tangent of some angle, in this case theta. Okay? So sine of an angle would be the opposite over the hypotenuse. And cosine of some angle is simply adjacent. A stands for adjacent. And H stands for? Hypotenuse. And then tangent of an angle is opposite over adjacent. That's right. Opposite over adjacent. All right, so SOHCAHTOA is how we remember that. What we're going to do is a little bit of practice here. Right off the top, I know I want the sine of angle A here. Sine is what legs are we looking for when we look at sine? Opposite. Okay, I'm just going to write that down. Opposite over hypotenuse. Cosine is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. And tangent is? Opposite over adjacent. So I'm just going to write those down just so I have them there for reference. But here's the important part. We want the sine ratio according to angle A. So I have to find angle A. Angle A is right here. So I'm going to put a nice big blue dot right there. So we are looking from angle A. Now the only one that always stays the same is the hypotenuse. Why is 13 the hypotenuse? It's opposite the right angle, across from the right angle. The hypotenuse always stays the hypotenuse. That one doesn't change. When we are looking from angle A, where is the opposite side? Yeah, it's opposite the angle. All the way across the triangle would be our opposite side. Where's the adjacent to angle A? 12. 12 is right next door, right adjacent to that angle A. 13 is also adjacent, but it's already taken as hypotenuse, right? Okay. So, according to angle A, what is opposite over hypotenuse going to be? 5 over 13. All right. According to angle A, what's the cosine adjacent over hypotenuse? What's the adjacent? 12 over 13. All right. According to angle A, what's our tangent ratio?
5 over 12.
Yes. Opposite over adjacent. Opposite over adjacent is 5 over 12. When I'm doing trigonometry, I've always got my finger on the angle so that I can go opposite, go all the way across. Okay? Questions on that one? Looking from angle C now, we're looking from a different angle. Now we're down here. So if I want the sine ratio opposite over hypotenuse, now from angle C, where's the opposite?
12.
Yeah, opposite is now 12. All right, so opposite over hypotenuse would be 12 over 13. Do you see how they're different? Sine of angle A and sine of angle C are not the same. All right, so we have to be very careful. All right, what is cosine according to angle C? Yeah, adjacent over hypotenuse would be 5 over 13. Adjacent, right next to it. Tangent is opposite over adjacent. 12 over 5. Yep, opposite over adjacent. 12 over 5.
So wait, sin and cosine can be like flipped. And then tangent is just you flip the denominator
yeah.
and the numerator.
Yeah, that's a lesson for Algebra 2.
Oh, that's actually easy.
Yeah.
Okay.
Yeah, it's not too bad. All right. So let's look at number 2 here. If I want my ratios, what's missing in this picture? The hypotenuse. Yeah, we got to figure it out. How can we figure out the length of the hypotenuse here?
9 squared plus 12 squared equals x squared.
9 squared plus 12 squared equals my hypotenuse squared. 9 squared plus 12 squared is 225.
Yep.
And then when we take a square root of both sides, our hypotenuse is 15. So we get 15. So yes, you will have to solve for the third side. All right, once again, this is our hypotenuse, so we know the hypotenuse, but everything else changes. All right, let's see. Sine according to angle W, so I'm looking from up here. What's the sine ratio? O over H, opposite over hypotenuse. All right, so what's the opposite side? 12 over hypotenuse, so 12 over 15. Now, we want this in lowest terms. Is 12 over 15 in lowest terms? No.
4 over 3.
Yeah, we can divide everything by 3. So 12 divided by 3 is 4, and 15 divided by 3 is 5, so 4/5. Also, you can math frac. You've got a calculator there to do that for you, so math frac it, if you will. All right, what is the cosine ratio according to angle W?
3 over 5.
Well, that's true, but 9 adjacent over 15, 9 over 15. 9 over 15 reduces to 3 over 5. Tangent is opposite over adjacent. So what's the opposite over adjacent?
4 over 3, 12 over 9.
Thank you, 12 over 9, which would reduce to
4 over 3.
4 over 3. Good. Questions so far? All right. Now we are looking from angle X, so from over here now, the sine ratio according to angle X, God bless you, is opposite over hypotenuse. Opposite over hypotenuse is 9 over 15, which reduces to 3 over 5. Cosine according to angle X is adjacent over hypotenuse. Adjacent over hypotenuse would be 12 over 15, which would reduce to 4 over 5. And then tangent according to angle X, tangent is opposite over adjacent. So opposite would be 9 over 12, which reduces to 3 over 4. All right, any questions on those? You're in Delta Math today. They're going to say a fraction in lowest terms or a decimal. All right, so here we did our fraction in lowest terms, like 12 over 9. So maybe you have to type in 1.33 as your answer, or it wants it in lowest terms, which would be 4/3. So you need to read the directions carefully, okay? All right, that's the easier part. Actually, I think that's harder. This is easier to me. So turn the page. This is where trigonometry becomes really, really useful, because it turns out that every single right triangle is similar to every other right triangle. And as long as we know the angle measure, then we can use it to find lengths of things. And so this is why trig happened so early on, because they figured out right triangles, and then they figured out that all right triangles are similar, and we can use that to find the heights that we need for everything we need to build, okay? So it came super fast. Now, I'm going to write down our little mnemonic device here. So, Toa, SOHCAHTOA, and we need this information to help us set up our little proportion. That's what we're going to do today. So I'm looking at number 4, and I have this angle that's 28 degrees. So we're looking from this 28-degree angle. Now, according to this 28-degree angle, which sides did they give me? Hypotenuse. And yeah, it is the small leg, but it's also, in this case today, we're calling it the opposite side, because it's opposite that angle they gave us. So if they gave us opposite and hypotenuse, which of these can we apply? The S, the sine. So we're going to write down sine according to our angle. So sine according to our 28-degree angle is equal to opposite over hypotenuse. So where's our opposite? X.
Over 19.
X over 19. So sine of 28 equals X over 19. And today, this is not physics, so you're going to solve it like I tell you to. This is a proportion. We've been solving proportions for like years now. How do you solve a proportion?
Cross multiply.
You cross multiply. We are going to cross multiply. So we are doing 1 times x is x, and then we have 19 times the sine of 28. Do not use your calculator yet. We are going to write down 19 sine of 28. That's what that means. It's just a product. And now we can plug it into our calculator. You do not use decimals until you're done, okay? That is the rule in math. So we can just plug that entire thing right into our calculator, 19 sine of 28, and it gives us the answer. You don't have to round anything off. There's no rounding error. We get 8.9. We want to round to the nearest tenths. Please read the directions in Delta Math to make sure that's what they want. All right, number 5. Here's our angle. We're looking from this 41-degree angle. Which sides are they giving us? Adjacent and opposite. Yep, opposite the 41 because it's all the way across. If we have opposite and adjacent, which piece can we use? Tangent, the T one. So tangent, according to my 41-degree angle, would be opposite over adjacent. What should I write?
X over 32.
X over 32. Opposite over adjacent. I'm going to put this over 1, and then how do we solve for x?
X equals
We cross multiply. X equals
41.
32 tangent of 41. 32 times the tangent of 41. And you plug that right into your calculator. 32 tangent of 41.
27.8.
27.8. Let's look at number 6. Here we have our 21-degree angle. Which sides did they give us for this one?
The adjacent and the hypotenuse.
Adjacent and hypotenuse. Adjacent and hypotenuse means we can use the cosine function. So we're going to use cosine of our 21-degree angle equals adjacent over hypotenuse. So what should I write?
X over 26.
X over 26. Beautiful. And you can cross multiply. So we get x equals 26 times the cosine of 21. 26 times the cosine of 21. 26 cosine of 21.
24.3.
24.3 when we round that up. Perfect. Okay, does anyone have any questions about the setup here? How do I choose sine, cosine, or tangent?
Angle.
From the angle, whatever sides they gave us, okay? All right, I have 2 more to do, and then we're done. 8 and 9 are a little different. So, again, we're looking from this 33-degree angle. Which sides did they give us? Opposite and hypotenuse. Good. So if they gave us opposite and hypotenuse, which function can I use? Sine. All right. So sine of 33 degrees equals what over what? All right. Opposite over hypotenuse, so 15 over x. So then, again, we are going to cross multiply, but now I have x times the sine of 33. So I'm going to write x times the sine of 33. And that's equal to 1 times 15, or 15. How do I get x by itself? Divide by? Thank you for correcting yourself. Divide by the sine of 33 on both sides. Those cancel out. And x is all by itself. And now this is 15 divided by the sine of 33. And we get 27.5. Alrighty. All right, last one here. We got a sine of, 43 degrees. Which sides do we have?
You have the hypotenuse and the leg.
Hypotenuse and which
The
leg?
adjacent.
Adjacent.
So cosine.
Yeah, adjacent and hypotenuse, we're going to use our cosine function. So cosine of 43 degrees equals adjacent over hypotenuse. So 36 over x. I'm going to cross multiply. What should I write?
36 equals x cosine 43.
Yeah, x times the cosine of 43. We just get to write x cosine 43. And then how do you get x by itself? Divide by cosine 43. So x equals 36 divided by the cosine of 43, which is 49.2. All right, you guys have any questions for me?
No.
All right, please get some help if you have it. Ask some questions, because it is a little weird to get started.